Hi, my name is Elizabeth and today we're going to be going over the ideal gas law. This is actually one of my favorites, so yeah, I'm excited to go through it. So the ideal gas law is PV equals nRT. Alright, whenever you're given, the main key here is if you're ever given grams or moles in your equation, along with any of these other values, you're going to use this one. There's no guesswork like maybe with Charles or Boyle's or the combined gas law, which one you're going to use. If you're given grams or moles, chances are you're going to be using the ideal gas law. So the first thing we're going to do is we're going to talk about what each of these actually mean. So P is pressure and it needs to be measured in atmospheres, like it needs to. In the other ones, you can kind of get away with not changing it to atmospheres, but in this one, you absolutely need to have it in atmospheres. The volume absolutely needs to be in liters. This is in moles. This is your R constant. Your R constant is going to be 0.08206. And the units are liters times atmosphere over mole Kelvin. This R constant is the reason why you need to have your volume in liters, your pressure in atmospheres, and your temperature in Kelvin. Because if not, this constant isn't going to work. So you absolutely need to have these in these values. Did I mention that you need to have these in these things? No, I did, right? Like 3 times. So please convert your pressure to atmosphere, volume to liter, mole or N to mole, and your temperature to Kelvin. So let's talk about directly proportional or inversely proportional, right? So if they're on the same side of the equation, they're going to be inversely proportional. So pressure and volume here, they're going to be inversely proportional because they're being multiplied, as well as your moles and your temperature. They're also going to be inversely proportional. If they're on opposite sides of the equation, they're going to be They're going to be directly proportional. So pressure and temperature are directly proportional. So are volume and temperature, pressure and moles, volume and moles. They're all going to be directly proportional if they're on opposite sides of the equation. So let's go ahead and do this practice problem. It says a cylinder of oxygen gas contains 91.3 grams of oxygen. If the volume of the cylinder is 0.00858 centimeters cubed, what is the pressure of the oxygen if the gas temperature is 21 degrees Celsius? So notice they gave you grams, right? Grams can easily be converted to moles using molar mass, so I know that I'm going to be using the ideal gas law for this problem. So let's see how that's going to look like. Well, let's actually highlight the things that we see here first, right? So obviously we see our grams, which we talked about, and this is going to eventually be our N after some conversions. We're looking for, so they gave us the volume in centimeters cubed, which is going to have to be in liters in a second. We're looking for the pressure, and they gave us temperature, which needs to be in Kelvin at some point. All right, so let's go ahead and do our conversions real quick. I'm gonna start off with the grams. So I have 91.3 grams of oxygen. So grams of oxygen is going to go on the bottom so that they cancel out. I'm going to have 1 mole of oxygen on the top. It's going to be around 32 grams because each oxygen is 16. So then when I divide 91.3 by 16, or my bad, by 32, I'm going to have 2.85 moles. So that's going to be my new N value. All right. And then I have my volume is 0.00858 centimeters cubed. So I know that 1 centimeter cubed is equal to 1 milliliter, and that there are 1,000 milliliters in 1 liter. So it's going to give us a pretty small value. So I have 8.58 times 10 to the negative 6 liters. Pretty small. And then I also have temperature, and that's given to us in degrees Celsius, so I have to convert that to Kelvin. And that's pretty easy. You just add 273.15 So 273.15 plus 21 gives me 294.15. So now that I have all these values, I can plug them into the equation. So I'm solving for pressure, so it's going to stay there. My new volume is 8.58 times 10 to the negative 6 is equal to the number of moles, 2.85 moles, times my R constant, times my temperature. So I'm going to go ahead and do the right side first. So this stays, this comes down. Times 10 to the negative 6. And let's see what that equals. So we have 2.85 times 0.08206 times 294.15. That gives me 68.8. And I'm going to divide by this value, by the 8.58 times 10 to the negative 6. Let's do that again. Parentheses are your friends. So that gives me a crazy large value. I got 8.02 times 10 to the 1, 2, 3, 4, 5, 6 atmospheres, which is crazy high. But that's okay because our volume was very low. So, alrighty, so let's go over what we just learned. So we learned that our ideal gas law is PV equals nRT. Your pressure has to be in atmospheres, your volume has to be in liters, your N has to be in moles, and your temperature has to be in Kelvin. And we learned that our R value, this is the R constant for anything involving gases, is going to be 0.08206 liter atmosphere mole Kelvin. And we learned that we need to convert grams to moles, centimeters cubed to liters, and to convert Celsius to Kelvin. And that is how you solve for your ideal gas law.